Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. And we meet again with this video. I have select a few questions from the collection of past year or Pspm questions in from your tutorial book, our tutorial book. And I do hope that all of you get ready. We try to look into a few different kind of questions. Hopefully that it helps you to continue with the rest of it. Okay. So, topic 2, differential equation for both of separable variables, integrating factor, and might be 1 or 2 of question of application. Okay, so radioactive substance. As we know that, let's say in experiment, one of scientists getting one we call radioactive substance, let's say in this amount. So and we call it stated at the time, the beginning of the experiment, where T naught equal to 0 and the weight of this mass is we call with initial mass of decays, and after one time, okay, and then the current of the weight of this we call 80 grams. So the weight of current, this will have come out we call that half-life of the we call the half-life, the term of half-life. So we related with physics, the things that you have learned before, we call it the subject of physics. So we relate with this topic here too. Okay, now decays means that the amount or the weight of this radioactive substance is getting less and less. So that's why we come up with the sign of negative there. Okay, so from dn dt equal to negative kn. Okay, so we divide it into two parts here. On left side of this equal sign, this is a house of n, and here is the house of the variable of t to the time. Okay, because we're talking about the we call n gram respect to the time of t. Okay, so then 1 over n dn equal to negative k dt, and we integrate left and right. Okay, this sign of curly sign here, you can put it here or somewhere, because this is negative k is a constant, not effective. We call the integral of this at all. So natural log of n equal to negative kt plus c. So come up with a constant of e, cancelling between the e and also the ln here, where n equal to e power of negative kt plus c. Okay, so using we call the rules of index, where a to the power of n plus n equal to a to the power of n times a to the power of n. So now, this is negative e kt multiplied with e to the power of c. So simplify this constant as an a e power of negative kt, where a equal to e to the power of c. Okay, so this is a equation of the we call for this question here. Okay, n stands for the current mass of the gram of this radioactive substance. Okay, and now where k is a constant, initially means that the beginning of the experiment, where t equal to 0. It's not that t, the time is 0, because time we have 12 noon, 1:30 p.m., 5:30 a.m. and so on. But this we consider as the beginning of the experiment, t equal to 0, and initially the amount is 80 grams. So it means that the beginning of the weight of this radioactive substance here is 80 grams. So n naught. After 100 years, t1, so 100, meaning to the next question here, we define the t for this question is in years. Okay, in a year, 1 year, 2 year, 10 years 100 years, 120 years. So when T equal to 100, it decayed to, and the current of the we call the substance here, which is 20 gram. Okay, so we use the first information where N, the current mass, the beginning, which is N naught. So N naught is 80 equal to A e power of negative k, where T equal to 0. 0 times negative k equal to 0, e power of 0 equal to 1. 1 times A equal to A, then A equal to 80. So the current mass equal to 80 e power of negative kt. Okay, so this is the initial mass, the beginning of the experiment. We found that it's 80 gram, and then after 100 years, then you use the next information given in the question. Then when T equal to 100 and N, the current mass is 20 gram. So the current here now is 20 equal to 80 e power of negative k, and T equal to 100. Then 20 divided by 80, 1 over 4, equal to e power of negative 100 k. Okay. Let's continue here. So how are we going to eliminate this e? We come up with natural log. Okay, natural log of 1 over 4 equal to natural log of e power of negative 100k. So cancel between these two, it is negative 100k. Then k equal to ln 1 over 4. Okay, it is natural log of 1 over 4 divided by negative 100, where natural log of 1 over 4 equal to, which is negative 1.386 divided by negative 100 divided by negative 100 equal to 0.01386. Okay, so then we call complete this equation here, where n equal to 80 e power of negative 0.01386 t. There you go. Now, express n in the terms of elapsed time t, which I think that we already found it. The first question here, A, here. Okay, the question of A here, and this is the one. So calculate the amount of substance remained after 120 years. So after 120 years means that with t equal to 120. So n equal to 80 e power of negative 0.01386, and t is 120. Okay, so for this one here, you may use any apps that you have in your smartphone or use a calculator. 80 multiplied with e to the power of negative 0.01386 multiplied with 120 equal to 15.16 amount of substance gram. Okay, so that is the first solution for the first question I select here, which is question number 2. In the order we call ordered origin of from the question, we call in the Pspm collection, your tutorial book. Okay, question number 2. Okay, what about this one here now? So the differential equation of this. Okay, so then dy dx plus 2 over x times y equal to an x. Okay, and given here, be careful, this is x equal to 2, y equal to 3. Okay, now I change the form of this 2y divided by x, make this one as a 2 over x times y, because we like to compare this with this one, the general form of integrating factor px times y equal to qx. But we can see here now, and here, so then px equal to 2 over x and qx equal to an x. So we can find that integrating factor of Vx, which is e power of integral of 2 over x dx. Okay, integral of 2 over x dx equal to 2 integral of 1 over x dx, which is 2 natural log of x. Okay, so it means that here it is e to the power of 2 natural log of x. Bring up here, and we cancel between e and the natural log here, then come up with x squared. Okay, this v, okay, vx, we multiply with every single term that we have in the equation in this form, which means that we're going to multiply here, okay, x squared dy dx plus x squared times 2 over x times y equal to x squared times x. Okay, class, let's take a look at this one here. If I derive respect to the x of vx, okay, vx x squared here, and then y. Okay, so let's expand this one by one. Derive x squared times y respect to the x. So derive x squared, it gives you 2x multiplied with y, and then we copy all this again, x squared, and it's time for derive the y to the x. Derive x y equal to 1, and because it's to derive the y respect to the x, we come up with dy dx. Okay, so let's compare this with this one here. X squared divided by x, then you see here it is 2xy, 2xy, agree? And then x squared dy dx, x squared dy dx. Can you see here now? Okay, so derivative of x squared times y equal to expansion of this process here, derivative differentiate of this, that you get here now. So if we integrate this one respect to the, recall the whole thing here, we integrate respect to the x, so we integrate everything here respect to the x. So you see that it is actually that we call normal, because integral is antiderivative, so between derivative and antiderivative, so it is vx times y, integral of this. Okay, so we integrate this respect to the x and integrate on the left side, so left side, and also integrate on the other side respect to the x. So this one derivative, differentiate and integrate it gives us Vx times y. Okay, and this one here, integral of x cubed dx. Again, first we differentiate derivative of this one here. Okay, the one that you see inside all this bracket. I'm sorry, I think that I make a mistake here. There you go. Because everything that you see in this bracket is derivative of x squared times y. So if we integrate between, if we come up with integration here, so integrate and derivative, one is differentiate and one is antiderivative. So we actually that opposite, we call cancelling each other. So then this one come up with a Vx times y, which is Vx equal to x squared times y, and integral of x cubed dx, x power 4 divided by 4 plus c. Okay. Okay, you may simplify if you want to, but let's say we like to find out what is the value of c. Okay, so it's time for us now to substitute the value of x and y, where x equal to 2, so 2 squared, times y equal to 3, then 2 to the power of 4 divided by 4 plus c. 2 squared equal to 4, 4 times 3 equal to 12, 2 power of 4, 2 squared is 4, 8 and 16. 16 divided by 4, 4. So then 4 plus c, then c equal to 12 minus 4 equal to 8. So now here now we refer again to this equation. It gives us x squared y equal to x power of 4 divided by 4 plus c equal to 8. So then y equal to, divide by x squared left and right, so x power 4 divided by x squared divided by 4 plus 8. Okay, so x power 4 divided by x squared over 4, and then this one is 8 over x squared. Okay, so find the value of y when x equal to half. So then when x equal to half, then y equal to 1 over 2 square divided by 4 plus 8 divided by 1 over 2 square. Okay, for question 15 here, let's make it short. It is 32.0625. So, guys, girls, we move to the next question then. Okay, so I select this question because one is, I think that is one for separable variables and one is for integrating factor. Let's try. Okay, for question of A here, where x dy dx plus 4 equal to 3y minus dy dx. Okay, let's try this. Okay, so 3y minus 3 dy dx. So my idea is, let's bring up, we call the dy dx here, negative 3 dy dx, bring to the other side, and it becomes x dy dx plus 3 dy dx equal to 3y, 4 here bring on this side become negative minus 4. Okay, and then factorize dy dx. Okay, dy dx, so then x plus 3 dy dx equal to 3y minus 4. Okay, so switch the position of this, bring it to the side, and 3y minus 4 bring to the side. So which I think that both are divided, right? So 1 divided by 3y minus 4 dy equal to x plus 3 dx. There you go. Okay, so now you can see here now there is all y, the variable of y on left side and x on the other side. So it's time for us to integrate this left and right. And this one here now, integral of 1 over ax plus b dx equal to natural log of ax plus b divided and derivative of ax plus b, which is a. Okay, so now it is natural log of 3y minus 4 divided by derivative of 3y minus 4, which is 3, equal to, and this one here, x squared over 2 plus 3x plus. Okay, so for question A here now, we are going to come up with the equation of y equal to fx. So then, multiply with 3 here. So 3 divided by 3, and also multiplied here with 3. So then natural log of 3y minus 4 equal to multiply with 3, 3x squared divided by 2 plus with 3 times 3x equal to 9x plus 3c. And come up with the constant of e, left and right. To eliminate the ln here, then 3y minus 4 equal to e power of 3x squared divided by 3 times with e power of 9x times e to the power of c, e power of 3c. Okay, and let's say if I change this in the term of a, but then because we have, okay, for this one here 3x, okay, not to make us what we call confused, then here 3 over 2, okay, 3x squared divided by 2. So make this one here e power of 3x squared divided by 2 plus 9x. Okay, and then 3y equal to negative 4, make it become positive. So a e power of 3x squared divided by 2 plus 9x plus 4, then y equal to 1 over 3 a e power of 3x squared divided by 2 plus 9x plus 4. Okay, so that is a solution for question number 12a. If you compare the answers of mine with the one that given now in the tutorial book, it's quite different, almost the same. Okay, the only thing is they come up with a cube, and how we simplify that is okay, which I think that from the step we can see this is what I get. Okay, now for question B, dy dx minus 2y equal to e to the power of x, and given that when x equal to 0, y equal to 2. So then class, for this question, it's clearly that we are going to solve this question using integrating factor, because this in the form of dy dx plus bx times y equal to qx. So according, if we compare between these two, then px equal to negative 2 and qx equal to e to the power of x. So the integrative factor of vx here, e power of negative 2 integral of negative 2 dx equal to e power of negative 2x. Okay, the integrating factor here, e power of negative 2x. So then multiply this v with this equation here. Okay, e power of negative 2x dy dx minus e power of negative 2x times 2y equal to e power of x times e power of negative 2x. Okay, so this one here is a derivative of e power of negative 2x times y equal to, okay, what about this one here now? Ex and e power of negative 2x. Ex times e power of negative 2x, then e power of x plus multiplication, and between these two we call same base, multiply, so x plus negative 2x, which is e power x minus 2x e power of negative x. So here is e power of negative x. And then derivative of e power of negative 2x times y equal to all this. So if we integrate respect to the x, means that we are cancelling between this derivative sign and integral sign here. So we integrate with the left side. So e power of negative 2x times y equal to integral of e power of negative x, which is e power of negative x divided by negative 1 plus c. Okay, now let's use the value given here where x equal to 0, then y equal to 2. So this is e power of negative 2 where x equal to 0 multiplied with y equal to 2, and this is negative e power of negative 0 plus c. E power of negative 0, negative 2 times 0 is 0, e power of 0 equal to 1. 1 times 2 equal to 2. And another e power of negative 0 here is 0, so negative 1 plus c, so then c equal to 3. Okay, so now it is e power of negative 2x times y equal to negative e power of negative x plus c equal to 3. Okay, so then y equal to negative e negative x divided by e power of negative 2x plus 3 divided by e power of negative 2x. Okay, so e power of negative x divided by this is just like e power of negative x divide minus with negative 2x. Okay, so negative times negative positive, so 2x minus x. 2x minus x equal to an x. So negative e power of x plus 3 e power of 2x. There you go. Okay, so class, this is a video. If I recall, my explanation is quite fast, so you may just make it slow, or you rewind forward and just control by yourself in which minute or minute that you really want to know of my explanation, and just go through it. Okay, so the next question, which I think that the last one here now. Okay, I choose the question that have a sign of what we call trigonometric function. Okay, so now dy dx plus cotangent x times y equal to 2 sine x. Which I think that this also are for the whole equation here is already in the form of general dy dx plus bx times y equal to qx. Okay, so from here, let's label it here now. Px equal to cotangent x, which is cos x divided by sine x. Okay, cotangent is also cos divided by sine, and qx equal to 2 sine x. So to find the decay factor here, Vx equal to e to the power of integral of cotangent, which is cos x divided by sine x dx. Okay, so to solve this, we are going to use a substitution, which is u equal to sine x, then du equal to differentiate sine, it gives you cos x dx. Okay, integral of 1 over sine, which is u, okay, 1 over sine, and cos x dx. Cos x dx is du. Then e integral of 1 over u, e natural log of u. Then cancel between these two is a u, and the integrating factor of this Vx equal to u, where u equal to sine x. Okay, so it means that this Vx integrating factor, we are going to multiply with every single term that we have in the equation here. Sine x dy dx plus sine x cotangent x times y equal to sine x multiplied with 2 sine x. Again, let's see the process of this reversely. Okay, derivative of sine x multiplied with y. Okay, so differentiate sine x, then you get cos x multiplied with y, and just now we differentiate sine, it gives you cos multiplied with y. It's now time turn for y here now, so we rewrite again sine x here. So differentiate y respect to the x, differentiate y equal to 1, and because it's to differentiate y respect to the x here, then come out with dy dx. Okay, so now look at this one here now on the left side. Okay, the left part here, we compare between this. Okay, sine x dy dx, sine x dy dx. Okay, exactly the same. But what about this one here now? It's not the same here, right? Sine x cotangent xy, cos xy. Okay, let's make some adjustment here, where cotangent equal to cos x divided by sine x. What can you see here now? Cos x multiplied with y, cos x multiplied with y. Now, we got both we call equal on left hand side. So, derivative of sine x multiplied with y, it gives you cos xy sine x dy dx. So, the derivative of this, it can give you on here. So, if we integrate respect to the x, well, actually that integrate this, everything here respect to x, it gives you back the Vx times y, where Vx according to here now is sine x, and it gives you back this one. Okay, we call cancelling between differentiate and integrate, then it gives you sine x multiplied with y. Okay, so now integrate here and integrate this one here respect to the x. So this is expansion of derivative of sine x times y respect to the x. So we call the process of derivative of sine x and y and give you this one here. So we integrate, it gives you back vx times y, which is sine x multiplied with y. Okay, so 2 is a constant, take it outside. Sine x. So sine multiplied with sine, integral of sine square x dx. Okay, so then here now we use the half angle formula for 2 integral of this, come up with 1 minus cos 2x divided by 2 dx. Okay, so 2 multiplied with this one here now, it is 1 over 2 integral of 1 minus cos 2x dx. So then, and here, okay, one over 2 integral of 1 equal to an x, and then half minus 1 over 2 integral of cos equal to sine 2x divided by 2. Okay, and plus c, so then 2 times 2 equal to 4. So now 2 divided by 2 equal to 1, x. 2 divided by 4 equal to 2 again. So minus sine 2x divided by 2 and plus with c. Okay, so y multiplied with sine x, and this is the answers. Okay, so which I think that we almost at the yeah, there you go. That's it. And I do hope that with these 4 questions and the solution that we got explained to all of you, helping you to continue with the rest of the question. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.